Okay, so what we'd like to do is basically these tasks, which is just trying to like a small conversion. This is not a big deal, basically just to make sure that you understand the code and update it. Now the first thing is the given DLL implements a generic linked list as we saw it in lab 3, which is basically this file over here. And then, well, now we'd like to use that to implement a DLL queue. Okay, and we have a linked list queue as a template to have a DLL queue. Now instead of having this, I would like it to be like this, and I don't need this anymore, and everything is okay except remove first, because now we call it, I'm sorry, no, it's delete from tail, and add to tail. Now where the queuing, we're deleting from the tail, and we are in queuing adding to the tail. Well, that's not how a queue works.
The from the head.
We dequeue from the head,
And
because we said first element is
head.
the head. So if I go here, this is giving me the head. So that's the get first. So that means I'm going to do this. And that's all I need to do. That's wonderful how complicated this is. And then we'd like to use this test double queue using this DLL based on something that we do have. This one. So let's, what does it have? Well, this is where it uses integer. We're going to use that. Okay, Control C, Control V, and then test double queue. And this time I'm going to use this DLL queue with double. And let's just see what is going to be changed. I mean, sorry, you said? Yeah, the scanner. This should be now next double. And done. Amazing exercise. So complicated. And write a test, test student. While that allows the same thing, but this time with a student. We don't have a student here.
We're gonna forward from lab 2.
Lab 2? Lab 3 we copied it as well, I think.
I think lab 4 we copied.
With 4 as well? Okay, we copied it
2
4.
or 4. They both have.
I think it's here. Student.
Yeah.
Let's copy it from here. And then
Just use it.
we have this. Now this is going to be the test queue. We're going to be, I'll basically change that to, let's close all these. Then a copy and paste for this one, because it's already having
the double,
it having the DLL test student. Test student queue, and then we have the DLL this time with student. And now we need to just do more things. So now if I'm going to read something, I need to enter the element in queue, and now I need to enter the name. And ID and GPA, something like that?
Yeah, ID, name, GPA.
So it's follow the logical order that we're used to. And then GPA. And I'm going to like declare this is the ID, another one string as a name, and double GPA. So I will use that.
We're gonna use a method constructor.
So this is new student, and with all of these, the ID, name, and GPA. Now there is nothing because it's complaining because they
Yeah,
have not
there's
been
no start.
initialized. And I'm going to initialize this first one. Then I need to do the same with the name. Next line.
Next on. What's the difference between them?
Well, if he writes his first name, last name, then next one is going to pick up only the
Only the first one, okay.
first name, while I call it reader dot next int, and we enqueue using this new thing. When we dequeue, and then if it's not empty, then we do that. If I don't want to ask the question here, I could just do some kind of. No, sorry, this is not what I meant. When I dequeue, remember we said that there is something. What is well, if it's empty, so it checks that already. So if it's empty, it returns null. So this is just you turn in the value, and then anyways, so I don't need to do anything. And to first give you the first element, and that's it. There's nothing else to do.
Okay.
That's enqueue dequeue, and that's done with this one. Now I'd like to use this array queue instead of having this double linked list queue. I'd like to work with this array queue, this one. I would like to, instead of using that, would like to use the array list queue and choose this in a generic queue. So just copy and paste. No, there's no control Z, so array list. So in this array list queue, instead of doing this, I'm going to have array list, and no, just array list. And it doesn't help because there's starts with the same, but I need to import java.utils, the util, not utils, okay, array list. Okay, so this array list, I want it to be of any kind of data type, but in order to me doing that, I need to make this to be generic. So if I just use like this, if I don't put anything, it will be an array list of objects. Because if we don't specify for all these, this is a generic class. But if I don't specify this, by default, it's going to be object. So I can just use it like this, or like this, then just to
Down.
not here. If I'd like to use like any data type here, or if you'd like to put some kind of restriction on the type of data types, whatever. Okay, then how about this? So I change that. Well, as you can see, there's no way for me to do that. Let's just leave this as it is.
We can also delete it, I think, because
Or I can just leave it and specify the size if I'd like to specify an initial size. And this time, when I'm initializing, because I know I need to initialize that, and there's the one that takes nothing, it will make the capacity of being 10. This is the default one, or the one that is going to be initial capacity. So if nothing is given, it will be like this 100. If something is given, then it's going to be this size.
can we remove this 100?
You can remove it if you want to, but anyways, that's not. If you do it, that's not wrong.
What it does,
Just initializes the size to be 100.
Okay.
But Dr. here, if we raise the size, it puts in and puts in instead of size, so we do so.
Same thing. It is the same thing, because n or size are the same value at this time. After this line,
Yeah.
at this time, at this line, size and n are the same. So you use n, use size, whatever, it's the same. I just put size because it's more meaningful than n.
Yeah.
Now for the rest, do I need to change something? Well, yes, there's no storage 0 equal L. I need to use some kind of a method.
Yeah.
Add, but then not this one, the one that need to specify an index, because I'd like to enter at 0 and the element is EL.
Yeah.
And you know, I don't like EL, honestly. I prefer elements. But now, what's the problem? So now it's taking T while it's expecting an object, and I'm sending T, and T can be anything. But why is this complaining? Now this was initially sound like a good idea, but no, it's just going to make things not work the way we want it to be. So we make it as an object, which means now everything is going to be stored as an object, and if I'd like to use that whatever data type, I need to downcast it. Now if I'm not doing that, then I need to change something here, and then still we cannot have that.
Object element. We change it to T.
Yeah, you're right. That's what I was looking for. Basically, this is not doing anything. This is basically, instead of having an object, I make a T. Now this is going to be consistent with what I did here. I said like this is an array list of T. Now the only advantage of doing this as opposed to object is that if I do this, it means now that everything that is going to be inserted is going to be upcasted to object. And then when I need to use it, I need to downcast it.
Yes.
Now if I do this,
No.
because I specify already the data type, so I don't need to downcast every time I'm using something from the array list. So that's the only advantage that I get from this in here. So that's why I need to do some kind of these minor changes. Now the same thing here. For this, I need to do this add and comma elements, and this is just maintaining the same thing. So instead of using this bracket representation of an array, I'm just using this add with specifying the size. The rest is going to be exactly the same. And when I'm dequeuing, I'm returning a T, and the temp is going to be T, and this is going to return the element that is at the first position. How do I return something from a linked list? Get. I said linked list. From an array list, it's get. So if you specify get, this is going to be getting the something from the storage. And guess what? This first element is going to be the same thing. It's also okay to do this? No. I was just trying to see if I can use that representation. So it's not possible to use that bracket, but I can use the get and add. Anything else? Same thing here. Storage.get, and this time instead of first is going to be I, and this is going to give me the position I, and that's it. Queue implemented as an array list. Okay, no, why would I do that? Now if I'd like to use this into this test double array list queue, now instead of using test double, I'm going to, where is the test double? This one, Control C, Control V, and delete this one, and test double array list queue. Now instead of DLL queue is going to be array list queue to be a double, and that's it. Nothing need to be changed, because this is going to be using this same methods while enqueue dequeue, this time with the just a double. And if I'd like to use this with the student, because that's the other thing here, there's a student array list queue and student array list queue, same thing, it's array list queue, Control C, Control V, and that's it. I mean, there's no big deal in this. So most of the work was only just creating the class array list queue. Now this is going to work with whatever you want.
Can we test
Which one?
the array list double?
Linked list or
No, for
array list?
Array list.
Array list double. This one, let's just right click and run the file. So testing queue. So in queue, let's say we put 5, and in queue 2, and queue 7. Let's print the queue. Good that you tested.
Because it didn't have any also.
Because now this, when I print, I'm printing this double, I'm printing the queue, and when I'm printing the queue, this is just going to print this thing, which is basically not going to work. So what's the problem, how to fix it? Where is this one?
String, I think.
But if you do this, this is the toString, but you need to implement our toString. So in this array list queue, is there any toString? There is none. But there's print all, that prints all. So when I do this, if I keep it just like this, it just uses the toString, but there's no toString. But what I could do, print all. And now, and thank you for making us in a test, because I would have not did this. So 1, I entered 5, and then 2, and then 7, and then if I print, now it appears 5, 2, 7. Let's dequeue. Front element 5 has been removed, and print again. So I have 2, 7. Let's get the front element. Since we're testing, let's keep testing. So the front element is 2, and then if we clear and print,
Because -1.
now we're trying to print, and it says array index out of bound exception because of this -1. Which one? I mean, this is not our file. This is not our file. This is our file. So let's go here and do this. Now we're printing regardless if it's -1 or not -1, which is going to be a problem. So what we should do is that we should do this only if it's not empty. So I'm going to put if else. So if it's not empty, how can I know if it's not empty? Is there something here? There's a question that I can use. There's a method. If it's not empty means I need to put it here. If it's not empty, do this. If it's empty, empty queue. So now I'm just displaying an empty queue when I'm printing that all. If it's empty, let's run again, Shift F6. Yes, because this one does not have any method. Shift F6, this one. Now if I try to print, it's an empty queue. But if I have something, and then print, it's going to print. And I think we tested all of them. Yes.
Now the size is 100 for them.
Now the size is, because let's see what when we use that here, what kind of, we did not specify any, so the size is 100 now. But if I specify a size, I will make it now just 10. Again, this one, Shift F6. Now it just works with 10. So what if I add more than 10?
It's gonna increase.
Let's see.
That's all.
That's 1, 2, 3, 4, 5, 6. But why are we doing this? We can just make a smaller size,
two or
and
three.
then let's put 2 and then see what is going to work. Why are we hurting ourselves like that? 1. Oh no, I said the Q. Okay, 1 again,
1, 2.
and then 1, 2. Now this is the maximum. 1 and then 3,
1.
and it's there. If I press 4 to print,
It's gonna show us.
no. So what happened?
Yeah, we EQ and a new and number.
So let's say I enqueue 2, and then I display now. So this. Let me clear everything, and enqueue 1, enqueue 2, and then print. So I have 1, 2. Now it's enqueue again 3, and if I print, where is 1, 2?
So we start from you, alright?
Let's try to see what happens when we enqueue. Alhamdulillah. Okay, let's see now when we enqueue. Now, in our case, when we had this, let me just show this. Oh no, that's not what I meant. Why this is not working? So let's follow what is happening. Now when we enqueue, we have, this is our array initially. So first and last are -1. When we start, first and last are -1. So this is first, this is last, -1, -1, and this is what we have. And we enqueue. We enqueued the first one. Is the last equal to size -1? What is size -1? So is last equal to 0? Size -1. What is size though?
Size was 2.
Size is equal to. So this is size of 2. Size -1, that means 1. Is last, which is -1, is it equal to 1? True or false?
Last. 1.
No, last is -1.
Oh, no.
Size -1 is 1, so that's false. Is last equal to -1? Yes, so we get in. We add the elements, add 0. So we entered, let's say 1. Then last is going to be 0. And then is first equal to -1? Yes. So first will become 0. And then we finish here. Okay, we get out. Done with this enqueue. We enqueue again number 2. Enqueuing number 2, what is going to happen is that is last equal to size -1? 0. Is it equal to 1?
No, it's not.
No. Is last equal to -1?
No.
No. So I go to the else storage dot add last is going to be incremented
To 1.
to 1, and then I'm going to be incrementing this first and then inserting the element at this last thing. So now this element is here, and we're doing fine up to now. Now I'm going to enqueue again. Let's say I'd like to enqueue this 3 here. So there's no room. So what is going to happen is last equal to size minus 1.
Yes.
Yes. So I don't need to ask the other question, because with OR 1 is true, the rest is going to be true. I get inside, I put add.
That 3 at index 0.
So now the 3 is going to be inserted here, and then the last is going to be 0, which means the value is here. First of all, I just replaced 1, and the value is still here, but we don't care. We just mentioned that our last is here and our first is here. So both of them are just pointing here. That's why when we print, it just prints
yeah,
only 1. So how to solve that?
Should not put 0. Something else here.
Well, we need to
The
make
problem
the
was in the question, right? Because we asked, is the L is equal to the size minus 1, and then when it was equal, that means the last is actually the last one. No, but we don't know how many elements we have. So there are different ways now. We need to know if if this one is the last, we need to increase the size, because there's an array list, so we can benefit from increasing the size by just adding. But the problem is this thing here, we don't know if it's empty or not, because what if now, for example, I entered 1, enqueued 1, enqueued 2, then dequeued. When I'm dequeuing, I'm removing this one, the last is still here, the last is still having this equal to 1, but the first is also now here. So now it makes sense now for that situation when this one was dequeued and I'm enqueuing, I should just enqueue at that place that was now empty. But now what I did, according to this code, even though it was full, it tried to enqueue and replace the value. So we have two options. Either we increase the size, or we don't allow something to be added if we have reached the capacity of the queue. Which one would you like to do?
We should increase the size, because that's the thing that
Array list, the advantage is that
Yeah.
it can increase easily. So now we need to ask the question that will make sure that we increase the size when we know that we're full. But how do we know that we're full? So there are two situations, as we have seen in the representation. There are two cases where we're full. If the size is the last and the first is the first, or the size, the last and the first are next to each other, which the last is
Last then-
before
yeah, before
the first. So this, which one? Yeah, this. So this is the situation where it's going to be full. So I need to ask a question. If it's full, then I'm going to increase. But hold on. If I increase and I'm in this situation, that's fine, because the last is going to be just moving around. But if I'm increasing and I'm in this situation,
you have to change first plus 1 and last plus 1 also.
no, that's what I meant.
What?
I meant like if, let's just remove these. Imagine now this is, well, this is too small to see that. Let me just put it like this. So this is the last, this is the first.
Yes.
Now this is, let's say, 1, 2, 3, 4, just to make it easy to see the order. Now this is full. I'd like to enqueue 5.
You have to.
Now this, what happens in the array list is just going to increase this.
No, we can make it increase in the beginning, right?
The middle.
You can
I-
increase
I-
also, you can insert from the beginning, but then it will still, what it will do, it will still create a bigger size, make different copies, because at the end, increasing will only increase from the right.
Right, okay.
Really?
Yeah?
Okay.
And then it will just copy the others, because the indices should not change.
Okay.
So if I increase that, so I'm not going to mess up the indices. So when I'm adding, I'm going to be adding to the right only. Then, now if I do this, my first and my last, if I add, where should I add now this in Q5? Now in Q5 should be,
After,
After 4, before 1.
No, after 3.
no, the 5 should be here. Between, after 4. You said 1, 2,
Yeah.
3, 4. That's how it was before.
right.
So the Q is 1, 2, 3, 4. Then if in Q5, it's going to be after the 4. Now the problem, how to do that? Because now if I'm increasing, what I need to do basically just put this one here and this one here and make the first to be here. Then this is going to show that this is empty in the middle. Then I can in Q5 at this place. But how do I know how many are here? It's a way I can maybe store this information in a variable and do some kind of calculation to count how many are from here until here until the end, the previous size. Then I increase the size and then just take these and put it there, put them there. But what if it's kind of a lot of things in this is not only 2 but maybe 10 numbers. I need to do that for all the whole 10 numbers. Well, I'm just saying that it's not impossible. It's possible, just need to have an extra variable and then do some kind of a loop. And then you're going to be able to do that. But I'm not, if you would like to, we can do it. Or I was about to say, oh, you know what? When we reach the size, when it's full, we just prevent from enqueuing.
So when we only add one element each time, right?
Yes. What do you mean queue, you mean?
Yeah,
Yes.
when you queue.
Yes. So you'd like to increase it only by 1, you mean?
Yeah, it's gonna increase this by 1. Every time you're gonna use
Okay, that's another thing. Is if you'd like to increase just by 1, that's another idea, which is simplifying things though. If we are just increasing by 1, what is going to happen is, if we're in this situation where which this is where was that we saw that question? Yeah, this one. When in a situation that we're full, not in this one, but in this one, then we just need to move around from
The first.
not the first, because I don't know where the first is. For example, if my queue is like this, imagine, look at this, look at my queue, 1 2 3 4 5 6 and I have 7 and 8. This is my queue. This is the first one, this is the last one. Now I need to increase 1,
Increase all the one between the.
so I'm going to add 1 and then move this here, 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 and move this here, which is still a lot of things to do. Anyways, it's not impossible, but regardless, even if you add 1 or a couple, since you're doing that, if you increase the size by increase only 1 and then you increase again, you're going to be moving too many times just for 1 extra memory. You better just add 10, for example, or an extra block, whatever it is, so you don't have to do that much often. So that's possible, but we need to implement it.
So I wanted to copy the information here, then return it after repeat.
What do you mean?
Copy all the data here
In another array,
in the another array,
and then
increase the original, then return the
Why would you do that? Just create another array, put them in the right order, and then this is going to be now your data. Why are you just going to copy them again? Just forget about this one, and this is now our array. We can do that too, but still you have to do these operations. You have to initialize your second array, so it can be. Well, I'm not seeing my mouse anymore. Okay. So so you can just put these values at the right places. So you still have to go through all the elements and do some kind of a loop or some kind of thing. Yes.
Now, if we add in between last and first, we don't need to do the moving the.
Yes, we do.
Why? But the array list does it by itself.
It increases from the right. Now, when you have this increase of the array list, if you reach this let's say like the size, it's going just to keep adding extra ones.
Yeah, but if, that's right. But when I say like add, then there's one that add index.
That's insert at.
Insert at.
Exactly.
So it's gonna move it by itself.
Exactly. That's what I wanted to also to point out, is that we can use not only just add, but insert at, which is available in the array list, and the insert at will just going to be moving all things up. But when I do insert at, now what is going to happen is that it's going to create in this new array, as you mentioned. It will just handle this for us, this moving for us. But just all we need to do, let's say if we had like, let's go back to this 1, 2, 3. 1, 2, 3, 4. Now, if we insert now here, it's just going to insert a new value inside here. Now, what is going to happen is all we need to do is make the last be incremented.
Yeah.
And that's much simpler for us. The array list we're going to deal with the moving things. How about doing that? So when I'm in queuing, then I need to check. Now, if I'm full, I need to do something. This is going to, if I'm in this situation, if the first is this one, the last is this one, and then I add an element, there's no problem. This code is going to work. But if I'm in this situation, then I need to check that instead of doing this add, I need to do insert. So how can I put that? Well, I can do into an if else if what? So how can I know that I'm in this situation? The same question that I'm asking if this full, if I'm in this case. If I'm in this case, what should happen? The storage dot insert at what? What is that? It's just well, add at. This is add. Insert the specified element at the position in the list. It just now, what position am I going to add it to? First?
After last.
Yeah, I can do first, and then I can increment the last, right? I can put it at the first, but then the first needs to be incremented as well, right? So first, then I increment the first, and then the last
Incremented.
should be incremented as well.
Okay. What about if we have it first and last? The first at the beginning and last.
So if we have something like this, this is going to be false.
We'll go to the second one, but the second one is also
The
wrong.
second one is, well, this one is true,
Yeah, true, but inside it's wrong. It's gonna do
But
the same thing.
so it's add. But now this one, if its last is equal to size minus 1, that's where in this situation,
Yeah, the first is.
so the last is here, so now it's going to add it at here. We don't want to do that.
So we have to use one if it's we can use if else at the beginning for the whole thing. If it's
Full.
full, sorry.
Yes.
Full, and and it's the first condition,
Yes.
then just add to the last at the end.
Now what do you want to do? You got me confused. You want to do another if
Yeah, no, for the whole thing, not only for this one, for the whole.
for everything?
Yeah,
Okay. If what?
if else.
If else? Okay. If what?
If
Is full?
Full is true,
Okay.
we're gonna go. We're gonna add.
So
Full
this is in the
add.
else then.
Yeah, this is the else.
This is in the else. Okay. If it's full, what do we do?
We're gonna just add. Use the add, the normal one.
But then you don't know which one is full. If it's full, which one it is? Because this is going to be full, and this is going to be full too.
Okay.
But yeah, what I wanted to do is something similar to what you're talking about. But this is going to handle the fact that it is full in this situation, and I would like to add another one to handle the case when it's full
Okay.
in this situation. So I wanted just to have another else if, and then in that else if I'm going to say that if the first is 0 and the last is the last, then I'm going to
Add.
just add without anything. So just add, but when I'm adding, I just need to increment the last. So when I do this add, now it's going to create extra space for it, and then I add this new element in here, and then just increase the last to be there.
And the last one we should also change it.
Which last one?
The
So if it's full now, I have two cases of full. Full like they're next to each other, we do this. Or full because they're in the first one is the first one, and the last one is the last one, and then I'll just add, which makes increase. This adds and increase the size and increase the last, and then we have this case when it's the last,
The size.
it's the middle, it's not.
What about the size?
And what about the size?
Because when we change the size, does it will it take?
That's a good point. Now, because when I change the size, this variable size, which is local, am I using it somewhere else? I say I use it here, yes. Which means now if I'm doing that, then the size has changed, and I need to get my new size. So
Can we read before?
once I add, then the new size is going to be updated, and this is where
Size plus plus.
I can just do no size equal to whatever the storage size now is, because I don't know now how many it was added, and generally when it adds, it adds by 10 or something. So then I get the size. Or what I can do, instead of doing that, just put this here. So I don't need
The
to.
condition, yeah.
So this is going to be only the initial size, but then this is not something, this might be confusing, because this size, we might think that this is always a size. So it's better to have something like this. In this case, or in this case, both of them. But notice I'm doing some things twice, in all these cases. So what I suggest we do is the following. Now this thing, I can just say if is full. So if it's full, there are two cases. Either it's the first one is equal to the last one, or I don't need to ask because there's only two cases, or this. So regardless of which one we do, we're just always going to take this and put it out, so I don't have to copy and paste. So if it's the first is equal to the last, I just add and then increase the first. Else I'm just add the element and don't touch the first. But on all cases I'm increasing the last and I'm getting the new size. So this is when it's full. And if it's not full, I'm just going to add to the first one because I'm in a situation where I'm the last and then there's still some space in the beginning. And else I haven't reached the last part. Okay, let's test that, and then I took some time from today, but I hope it was worth it. So let's just add
I think it's worth it.
the size. Where was the size? I put the size to be 2, right? So let's go back and put 1, and then 2.
No, one.
No.
1, 1.
1 again,
1.
and then 1, 2, and let's print. So we have 1, 2. Now let's enqueue 3 and print 1, 2, 1. Where did we get that 1 from?
Repeat.
From the first.
Because we dequeued, remember? Let me just clear. It will work 1, 1, 1, 2, 1, 3. Now if I print,
1, 2, 1, 1, 3, 3.
how is that? Because we haven't not changed the, we have not checked when we dequeue what happens.
Yes.
Now when we dequeue, it just gets this. If it looks, if there's only one element, that means the first is equal to the last. It does something. And then else, the first is equal to size minus 1. So if the first is, and the last one, the first becomes the first. Else, we increment just the first. But the clear just puts first and last equal to minus 1. So when we print, it checks that if it's empty, but if it's empty, it just checks if it's equal to minus 1. So I don't see clearly what's the problem, but because of the time, we'll talk about that inshallah at the beginning of next lecture. But have a look at it. If you're able to find a problem, that would be nice, so you can share it with us. And if you find a problem, okay, I never do that generally, but if you find a problem, you get an extra mark.
Can you upload this one?
Yeah, I will.